So, class, welcome to the lecture number 14 of the course Power Station Practices. Okay, so in lecture number 13, I started I finished at the topic which was the method or methods for determining the depreciation. So, I again repeated what is depreciation. Depreciation is nothing but the reduction in the cost of the value of plant or equipment due to wear and tear. Okay, then I told you that there are commonly three methods that are used for calculating the depreciation charges, which are straight line method, diminishing value method, and sinking fund method. So I will take all these methods one by one. So the first method is the straight line method. Straight line method. Okay. So what basically is a straight line method? In straight line method we get a curve which is a straight line. That is why it is called as a straight line method. So in straight line method, why the line is straight? The curve of the this method is straight because what we do in this method constant depreciation charges are made every year. Okay, on the basis of the total depreciation and the useful life of the property. What we do? What I'm trying to say, first let me write it down. I'm saying that constant depreciation charges are made every year on the basis of total depreciation and the useful life of the property or plant. Okay, what we do, constant depreciation charges means, okay, this means that, okay, in the first year if we are charging as depreciation, we are depreciating suppose 1000 rupees. In the second year again we are depreciating 1000 rupees. Every year we are depreciating 1000 rupees. Okay, so that is why the graph will come. The graph becomes a straight line, and it is called as a straight line method. So how we make annual depreciation charges? Suppose I am saying that consider that X is the, I will write it capital X. Suppose X is the initial cost of the equipment. And Y is the scrap value. Scrap value means the value of the equipment after its useful life is over, or scrap value of the equipment after the useful life is over. After the useful life, in simple words. Because you know what is scrap value means, if the useful life is over, still means these equipments, they are made of some metallic parts, so you can sell them in scrap. Okay. So, and I am saying, suppose that the useful life is N, capital N is the useful life of equipment. Okay. So how do we make this depreciation? I am saying constant depreciation charges are made every year on the basis of total depreciation and the useful life of the property, plant. Okay. So what is total depreciation? I am saying on the basis of total depreciation and useful life of property at plant. So if X is the initial cost, Y is the scrap value of the equipment after the useful life. So what should be the depreciation? Total depreciation should be equal to initial cost minus scrap value. So this is your total depreciation. Okay, so what is straight line method? It says that constant depreciation charges are made every year on the basis of total depreciation and the useful life of the plant or property. This is the useful life of the plant. So how will you calculate annual depreciation? Means what are the depreciation charges each year? That is called as annual depreciation charge. So I will write it that annual depreciation charge, in short ADC. This is not analog to digital converter. Okay, this is annual depreciation charge. So it is nothing but we are saying constant charges are made each year. Whatever is the depreciation charge during the first year, same will be the depreciation charge during the second year, and same will be the depreciation charge during the nth year. Okay, so it is given by total depreciation depreciation divided by useful life in years. So ADC is nothing but total depreciation is nothing but x minus y divided by useful life is n. Okay, so x is the initial cost or the investment, y is the scrap value after the useful life is over, and n is the useful life in years. So how the graph of this annual depreciation charge it will look like? Okay, or this straight line method, the graph will look like, here I will draw the graph like this. Okay, so I am saying initial cost was x and scrap value, suppose I am saying a scrap value was y, and useful life was n years. So this is years, this is n years. So I am saying that after this after the useful, when the useful life is over, the cost of the plant will reduce from this to this. So the graph will go like this. This is the graph for the straight line method. Means each year, why is it straight line? Because each year we are saying that constant depreciation charges are made. Means whatever are the depreciation charge made during the first year, same will be the depreciation charge made during the nth year. Okay, for same for the first year, second year, third year, and whatever is the value of n, so it is 20, then during the 25th year same depreciation charges are made. Okay, so that is why the graph is a straight line. Okay, so what information do we get from this graph? Okay, what information we get from this graph? So this graph shows that the cost of an equipment, if the we see the cost of the equipment, it reduces uniformly. Okay, it reduces uniformly from its investment or initial value to the scrap value. Okay, so I will write graph shows that cost of equipment reduces from its initial value. What was the initial value? X, scrap value y uniformly. Got it? So, but if you no, there are certain disadvantages of this straight line method. What are the disadvantages? Means that we are saying that the we are assuming that the constant depreciation charges are made every year. Okay, which is not correct. Okay, because we cannot have same depreciation charges each year, because the cost of the equipment is reducing after each year. So having same depreciation charges each year, it is not means it is not a good idea. Okay, so and the second this disadvantage is that whatever we are whatever annual depreciation charge we are means saving during the first year. So if it is to be saved during the second year, so it should gain some interest during the second year. Okay, that interest is not accounted in this straight line method. So these are the two disadvantages. So I will write the disadvantages here. Disadvantages. So what is the first disadvantage? It says that Uh, assumption of constant depreciation charge every year is not correct. Assumption of constant depreciation charge each year is not correct. Is not correct. And the second was about the interest, and I will write it like that. This method does not account for the interest on the money which may be means drawn during the accumulation. Method does not account for the interest which may be drawn during accumulation depreciated amount. Because if you are saying some money in the first year, maybe at the end of the 25th year the amount doubles. Okay, so this interest has to be accounted somehow. Okay, otherwise it will means that loss is to be means paid by the utility. Okay, the second value method was, so this was the first method. Second method was diminishing value. Diminishing value method. So what is diminishing value method? So in diminishing value method, depreciation charges are made every year, but at a fixed rate. At a fixed rate on the diminished value of the equipment. Diminished value of the equipment, what I am trying to say, I am trying to say, suppose that for 25 years each year I am charging a depreciation charge of 5%. Okay, so for the first year I will make a charge of depreciation amount of 5% on the initial investment during the first year. So now at the end of the first year the value of the equipment, it has reduced. Now on that reduced value of the equipment I will again charge 5%. Okay, got it? अगर मैं कह रहा हूँ मेरा पहले साल में 100 रुपया था, 100 रुपया मेरा इक्विपमेंट का कॉस्ट था और मैंने 5% डेप्रिसिएशन लिया, तो सेकेंड ईयर के एंड तक मेरी 5% के हिसाब से डेप्रिसिएशन हो गया. सेकेंड ईयर के एंड पे मेरे इक्विपमेंट का कॉस्ट कितना रहेगा? So 100 minus 5, it is rupees 95. So again I will charge 5% as depreciation, but on which amount? On 95 rupees, not on 100 rupees. Okay, so this is called as diminishing value method. However, let me write it down first. So depreciation charges are made every year at a fixed rate, on the diminished value of the equipment. That is, depreciation charge is first made on the initial cost of equipment and then to its diminished value. That is, depreciation charge is first made on initial cost of equipment and then to its diminished value. Okay, so suppose that I am saying that annual unit depreciation is X. Okay, I am saying let annual depreciation rate is X%. Small x I am taking here, and X is to be calculated in terms of X and So I am again using the small x here and capital X and Y here. So I am write P and S, P and S. Where what is P? Initial investment, initial cost, and S is scrap value. So in order to avoid confusion, I am not using capital X and Y, capital Y as initial cost and scrap value. Instead of capital X and Y, I am using P and S. S is the scrap value and P is the initial cost. And again, N is the useful life. Useful life. So I am saying P is the initial cost and X is the annual depreciation rate. Okay, and I want to calculate X in terms of P, S, and N. PS and N. So tell me, what is the value of the equipment? Initial value. Initial value of equipment is nothing but P. Okay. What is the value of the equipment after 1 year? Equipment after 1 year, it will be P is the initial minus depreciation. Depreciation is nothing but X into P. Got it? So I will take P common. I am left with 1 minus X. Okay, so this is the value of the equipment after 1 year. This is initial value, X is the depreciation. So XP is the X percent is the depreciation on initial value. So P minus XP is equal to P into 1 minus X. So this is the value of the equipment after 1 year. Now value of equipment after second year, it will be, so what was the value of the equipment after first year? It was this P into 1 minus X. Okay, so this is a diminished value. No, we will charge depreciation on this amount, not on this amount. Okay, though the rate of depreciation will be same, but the depreciation will be charged on the diminished value, not on the actual value at the end of the second year. So P into 1 minus X minus P into 1 minus X into X. Okay, if you will solve it, it will be P minus Px minus Px plus Px square. So what I will do here, I will take P common. So I am left with X square minus 2X plus 1. Okay. Let me not write it like this. I will write it like this. So Px square into Px 2Px. I will write it like P common 1 minus 2X plus X square. Okay. So if else I will solve it further, it is a square minus 2ab plus b square. So it is a minus b whole square. So it will be p into 1 minus x whole square. It will be equal to p into 1 minus x whole square. So this is the cost of the equipment or value of the equipment at the end of second year. So value of the equipment at the end of second year. So let us calculate the value of equipment at the end of, so what was it, what you are taking n capital N or small n here? Small n. Useful life is small n. Will be at the end of n years will be, or nth year will be p into 1 minus x raised to power n. Okay, so this is the value of the equipment at the end of the n years useful life, after the useful life, which is nothing but equal to the scrap value. So I will write p into 1 minus x raised to power n is equal to s. So I can write 1 minus x raised to power n is equal to s by p. Here from here I can write x is equal to 1 minus s by p raised to the power 1 by n. So where x is the rate of interest. So I will write it here, x is equal to 1 minus s by p raised to power 1 by n. Got it? So how the graph will look like? The graph of this curve will be like this. Okay, so this is your scrap value S, and this is your initial value P, and this is your useful life N. Okay, so you see here the line is not a straight line, the curve is not a straight line. Okay, so what is depreciation here? Depreciation is this, total depreciation is this is the total depreciation. Total depreciation, I haven't shown total depreciation in case of here. So in case of the this straight line method, this was the total depreciation. Total depreciation. Okay, so from the graph we observe that depreciation charges are heavy, okay, heavy in the early years, okay, and decreases to a low value in the later years. Okay, starting के years में depreciation ज़्यादा होगा और last के years में depreciation कम होगा, which is clear from the slope of this line. Okay, but still I can say from this line I can say that depreciation charges are high during starting years and low during later years. Okay, so but still again this method again has some disadvantages. What are the disadvantages? So it has two disadvantages. Means low depreciation charges are made at the end of the later year, at the and towards the end of the useful life. But you know that towards the end of the useful life means the maintenance and repair work is more. Okay, so means here the depreciation charges should be more, but here depreciation charges are less. Okay, so I'm saying low depreciation charges are made in the later years when more maintenance is required, when maintenance and repair charges are high. And what is the second disadvantages? Again, depreciation charge is independent of the rate of interest. Means like just the second disadvantage, same as the second disadvantage of straight line method. So we are not again considering means interest in this type of method. Means whatever amount you are means taking as depreciation at the end of the first year. So what interest it can gain in the bank at the end of the second year, it is not considered here. Okay, so means interest part is again omitted. So let us study the third part of the curve. This third method of calculating depreciation, which is called as sinking fund method. So what is sinking fund method? So what we do, we first means depreciation charge is made every year and the interest compounded on it annually. Okay, we calculate both depreciation charge also depreciation charge is made every year and interest compounded on it annually is also calculated. Okay, so since we are saying that constant depreciation charge are made in such a manner, okay, this constant depreciation charge means here again we are making constant depreciation charges, but these charges are made in such a manner that the total annual installment plus the interest accumulation, it should become equal to the cost of the replacement of equipment after its useful life. I am again repeating that constant depreciation charges are made in such a manner that the total of annual installment plus the interest accumulation equals to the cost of the replacement of equipment after useful life. You please note it down in your own words. You write it down in your own words. It is a very important line. So I am saying consider the initial cost as, again, initial cost as P and scrap value be scrap value be S and useful life be equal to n years. Okay. So this is the scrap value of the equipment after the useful life of the equipment. Okay. So again assume that annual rate of interest in decimal B. Again assume that this one page is over, that annual rate of interest in decimal B, suppose I'm saying it is R. Okay, so this is the rate of interest, because whatever depreciation charge we are calculating, we are getting some interest on it. So I'm saying let the rate of interest be equal to R. Okay. So cost of replacement of equipment will be, after the useful year, cost of replacement will be given by nothing, initial value minus scrap value P minus S. So this is the cost of replacement. Now we are assuming that an amount equal to Q, I am saying, is set aside as depreciation. So this amount Q is equal to Q is set aside as depreciation charge every year, and some interest is compounded on this depreciation charge, so that the amount becomes equal to this depreciation charge plus interest on this. Every year we are keeping some amount aside which as depreciation charge, and we are getting some compounded interest on this depreciation charge. Okay. So what we are doing, we are saying that if this depreciation plus the compounded interest on this depreciation, it should become equal to P minus S, that is the replacement cost of the this equipment after n years. Okay. So I'm saying an amount equal to Q at annual interest of R will become equal to Q into 1 plus R raised to power n at the end of the n years. What I am saying, an amount Q at an interest of R will become equal to Q into 1 plus R raised to power n at the end of n years. Will it be or not? Simply compound interest formula. This is a depreciation every year, and this is the rate of interest which we get on this amount which we are keeping aside. So I am saying depreciation amount at the end of n years will be I am saying the amount Q at an annual interest R, okay, when kept in bank, becomes equal to Q into 1 plus R raised to power n at the end of n years. Okay. So tell me, thus you can say that amount Q depreciated. But when are we depreciating this amount? We are depreciating it at the end of the first year. Depreciated at the end of first year. First year becomes equal to Q into 1 plus R raised to power n minus 1. Are you getting it? If I am saying this, it will become 1 plus R raised to power n minus 1. We am saying because this amount Q which I am saying keeping aside as depreciation, I am putting this amount into the bank at the end of the first year. So if total life of the plant it is, or equipment it is n years, so deduct 1 year from that life. So how many years will be remaining? N minus 1 years. Okay. So I will say the amount Q deposited at the end of the first year becomes equal to q into 1 plus r raised to power n minus 1. Okay, at the end of the n years. Okay, got it? So it is simple. Means if you have read banking in your 10th subject, you know what is this thing. Okay, so I am saying no amount deposited. This is at the end of the first year. Means if you are depositing Q at the end of the first year, it will become Q into 1 plus R raised to n minus 1 at the end of n years. Similarly, amount deposited at the end of second year becomes equal to q into 1 plus r raised to power n minus 2 after n years, or at the end of n years. Similarly, amount deposited at the end of, so second year, third year, fourth year, fifth year, then we came to the last at the end of the n minus 1 year. n minus 1 years means second last year. अगर टोटल 19-20 साल है तो 20 minus 1 19. At the end of the 19th year, whatever you will deposit, you will gain interest on that money at the end of the 20th year. So at the end of the 1 minus 1 year becomes equal to q into 1 plus r raised to power n minus, this will become minus n minus 1. This was second year 2, this was first year 1, after second year 2, after n minus 1 years n minus 1 year. I will write it at the end of nth year. Okay, so what will be the total amount? First, in the first year you are getting, at the end of the first year you are getting this amount, at the end of the second year you are getting this amount, and at the end of the n minus 1 year you are getting this amount. So you will add all the amount. So the total amount will be equal to what you have got at the, what money you have deposited at the end of the first year. So you are getting some interest on that money at the end of the nth year. Okay, that interest plus the amount which you have deposited is given by q into 1 plus r raised to power n minus 1 plus no, at the end of the second year you are depositing some money, and it is at the end of nth year it will become q into 1 plus r raised to power n minus 2. Okay, then at the end of third year you are depositing some money, and at the end of n year it will become q into 1 plus r raised to power n minus 3. Similarly, you are depositing some money at the end of the n minus 1 year, and at the end of the n year it will becoming equal to q into 1 plus r raised to power n minus 1. So if you will see this equation means it is a geometric progression series. Okay, it is a geometric progression series, and its sum is given by total summation is given by q into 1 plus r raised to power n minus 1 divided by r. Okay, hope it is visible. So I am saying this is a geometric progression series, and its sum is given by q into 1 plus r raised to power n minus 1 whole divided by r. So I am saying this is as the equation number 4. So this is the total amount which has been accumulated at the end of the nth year, and this amount must become equal to the cost of replacement of the equipment, which is nothing but P minus S. So can you calculate Q from this point? Okay, so if you will see from this equation, if you will see what will be Q equal to, Q will become equal to, if you will solve this equation, I'm not going to solve this equation in steps, I'm directly going to write down the answer. Q will become equal to P minus S multiplied by R divided by 1 plus R raised to power n minus 1. Okay, so these are the annual depreciation charges. This is how you will get the annual depreciation charges every year. Okay, so the problem of the interest that has been solved here. Okay, the interest which we are avoiding in the first two methods, it has been accounted for in this method, seeking fund method. So I think it is enough for today's lecture. In the next lecture, I will solve three numerical problems or two numerical problems related to this economics of generation. And in the same lecture, I will start another topic, which is nothing but selection of choice and number of generating units. How will you select the size of the generating units? What should be the size of the generating units? And how many and how can you choose the number of generating units? Okay, so which is means I will cover in the next class. So watch these videos, and in case of any confusion, you can call me or you can drop me a message on this Google Classroom. Okay, thank you very much.